All right. So, welcome everyone. I guess we'll go ahead and get started. So, I am Matt Heon, and the first thing I'm going to tell you is that the title of this talk is actually a lie. It's not 7 years, it's 8 years. I counted after. I only thought to count after I did the title. Sorry, everyone. All right. So, starting off, I am not going to go in depth on the reasons why there was a split between us and Docker. If you want that, attend Dan's talk right after this. He is going to do a much better job of it than I ever could. But if you are interested in generalities, I spent the first 2 years here. I started full time in 2015. First 2 years, I spent working Docker upstream. And that was an interesting experience. A lot of what we were doing was not acceptable or compatible with the Docker vision, and at the same time was necessary for us and our customers. So we had pull requests go into, we called it friction at the time, where basically they sat there, they were not reviewed, they were not merged. At the same time, we had to ship them. So this was a suboptimal experience that eventually broke down completely. And at some point, we had to sit down in a room and say, we can't ship Docker anymore. What are our options? Obviously, there are two things you can do at that point. One, you can fork it. We could have had Red Hat Docker. Well, we probably couldn't have used the name Docker, but you get the impression. Our own version of their code base, keeping very close to what they were doing, and basically just shipping our custom set of patches. Alternatively, we had an opportunity to strike out on our own and do something new. And pretty obviously, from where we sit, we decided to do something new. So why we rewrote is largely because we felt there were opportunities to do better. So Dan Walsh can tell you a lot about how much the original Docker server model annoyed him. The fact that we were trying to do things like auditing and things of that nature, and we just couldn't, because it's impossible to know who is talking to a Docker daemon over HTTP. We cannot know for certain who is contacting us for things like security RBAC, for things like auditing, and that made our lives very difficult. So if we were going to do a rewrite, we were going to move to a fork exec model, we were going to do daemonless. There were a bunch of good ideas at that point. And the biggest thing we wanted to do was work out of the Cryo repository. We already have this tool called Cryo. It's the runtime for our Kubernetes distribution. It was built exclusively to cater to Kubernetes, so we knew there was going to be a lot of work involved to get it ready. But at the same time, it gave us the opportunity to do some serious code reuse, and we expected it would get things going faster. Yeah. Now, one of the interesting things is that we initially were not thinking about rootless. Rootless came to Podman, I want to say 3 to 6 months after we started, and I was not a fan initially. I saw this giant pull request from Giuseppe Scrivano, brilliant engineer, but by God, he cluttered up our repository. It was pristine before. It was so clean. And then Rootless comes in, and we have to add workarounds for everything. Networking is completely different. Storage configuration, God help us, completely different. So I looked at this, and I was very critical. I think Dan eventually had to sit me down and say, look, this is incredibly cool, and we have to do it. And he was completely right. The other big question of the day was, what are we going to do for CLI? And in the end, not very much of a question. If we're going to be doing a tool that will replace Docker on RHEL, which was eventually what we thought we had to do, you have to provide a transition. And that transition has got to be command line compatibility. So the initial Podman goal was alias Docker equals Podman. But we only meant that in a specific narrow sense of the command line. You will be able to take any existing Docker CLI and run it on Podman. So at first we get started in the repository of Cryo. and we were not called Podman at that point. The name was K-Pod. Fun bit of Podman lore. During the first meeting, someone floated the name Torpedo, shot down for being a bit too on the nose. But after about 3 months in trying to work with Cryo, we eventually come to the decision that it's not working. Cryo had too narrow of a scope. It required too many tests to get into production. Basically, Cryo was already stable, and what we needed to do was iterate fast. It was not compatible with the model they were doing. So, new thought. We branch off into a separate repository, we build our own thing, and at some later point, we come back together. We make Cryo based on the new library we're going to build. We're calling it LibPod at that point. And we, once again, have a big happy family based off new code. So, after we renamed to Podman and released, I think it was 002, we had most of the basic Docker features, but we were still missing a bunch of stuff. It took us about a year of fast iteration, releasing once a week, to get from Podman 02 to something vaguely approaching stability. And at this point, strong focus just on getting all the basics implemented. We needed something that was going to be ready in time for RHEL 8, which means all the basic features, cover those first. I will start off by saying that I used to not have access to Stable Diffusion, and my slideshows were considerably more boring, so thank you, AI, for this. Podman 1.0, 2019. This was actually, I think, a January release, so this is very early in the year, and it was the first release that went out in RHEL. I believe this was out in 8.0 and something in 7. And looking back, I took a look at the release notes from the 1X series at some point over the last week. We were not stable. Dear God. Major features were missing and were being released on a regular cadence. We did a complete overhaul of our locking model. I have no idea how I slipped that through RHEL. Somehow, we managed to not break too many people, and we were able to, at this point, do quarterly releases, thanks to RHEL modularity, rest in peace. So we are pushing down RHEL or Podman 1.0, 1.2, 1.4, 1.6, just trying to get as new code as we can in people's hands because we are fixing major bugs on a weekly basis. 1.6.4 is the first really polished Podman, largely because the OpenStack team decides to transition their product over to using it, and they have stability requirements, which means we start getting bugs and we start fixing bugs. 1.6 gets so many iterations of bug fixing that it is really the first time I would say Podman becomes actually usable. Now at this point, up comes an interesting question. As I said earlier, we start off with this intention of we're going to branch off from Cryo, but we're going to come back. We are going to take the existing Podman codebase and we're going to unify with Cryo, and we're also going to try and unify with Builda. So at that point, we had 3 different ways of launching containers. You have Podman, daemonless, and provides basically all the functionality of Docker, so very rich debugging capabilities, rich container runtime capabilities. Then you have Cryo. It's a daemon. It's optimized specifically for performance. It has a lot of requirements that are unique to Kubernetes, but a lot of non-requirements. Like Kubernetes doesn't really care about persistence. If something goes wrong, it just kind of cycles things until it starts going right. It gets rid of pods, it recreates the pods, easier than doing a lot of other things, which means Cryo doesn't really care if a lot of its state just goes away on a reboot. Can't say that about Podman. People get very angry if we take their containers away when they reboot their systems. Builda, meanwhile, has containers for one specific purpose, and that is the run instruction. So if you run a Docker file, container file out of Builda, and it has a run in it, that has to run in a container. So Builda has a very minimal definition of a container. It does very little in the way of setup. And our idea was, at this point, we're going to make a single glorious runtime that will do all 3 of these very disparate use cases. At the time, I was being very careful that all the code that we checked into libpod, the core container library, was going to work both as a daemon and daemonless. That was going to be as lightweight as we could make it. The problem is that this was never really going to work. Builda did not want these patches because they added so much complexity. Like, we were going to take Builda from being small and lean to being very complex and honestly probably less usable than it is right now. And on Cryo has the big problem of performance. Can a daemonless engine like Podman, especially one that was as early in development as we were, provide the same degree of performance that they get with their architecture that doesn't really store state, that doesn't have to do very much in the way of locking, that only caters to one specific use case and does it very well? And we did a lot of discussions about this. There were several meetings about it. None of them produced a satisfactory result. In the end, the idea of unification just gets scrapped. Now, the big lesson here is sometimes there isn't a perfect technical lesson or technical solution, but even when there isn't, there are consequences. If you have ever done a Control-C on a build and you've had, after that, images pop up saying you cannot remove this, there's a container associated with it, but you can't find that container, this is a result of our split here. We still have 3 different ways of creating containers, and though we've done a lot to bridge the gap over the years, we've done a lot to be able to see these containers that weren't created by Podman, there is still a world where weird things can happen, and you can get into strange states because of this. So this is an ongoing pain point, and unfortunately, it's not one we've ever found a satisfactory solution to. Now, on to evolution. So we start off with a very simple mission statement. Alias Docker equals Podman. Podman is a command line compatible drop-in replacement for Docker. Core problem. Not everyone views Docker as a command line. Docker offered a number of other things, including a robust HTTP API and Docker Desktop, the ability to run on things that aren't Linux. So our initial mission statement worked okay for a while, but eventually we are starting to get an increasing number of people asking, but where's your Podman API? How do I talk to Podman and get it to do things? And we have an abortive affair, let's call it, with something called Varlink. The less said about that, the better. Let's just say that it lived in 1.0 and died very quickly thereafter. And after our first attempt at an API failed, we sat down and had a serious look at what do we need, but also what do our customers need? What do the people using Podman want? And the end answer to this is more Docker compatibility. They have tools they've written against an existing Docker API. They want that to just work. So we end up producing Podman 2.0. 2.0 is the REST API release. We provide nearly full support for the Docker REST API. There are a few things that got left until 3. And then from there, we have a further question. We have gone further than our initial mission statement. What can we do after this? Is there anything? What's the next stage for growth? And the next stage for growth is something that Brent Bowd, who of course regrettably cannot be here, sorry. Brent Bowd has this idea that, let's go into the final bastion that is Docker exclusive. Let's try for Windows and Mac, because Podman is fundamentally a developer tool. You can definitely use it in production. We provide it in RHEL for that purpose, but a lot more people are going to be running containers on big clusters as opposed to single systems. If you want a single system thing, that's probably a laptop, that's some developer doing work, and most of those people are going to be on Mac. They're going to be on Windows. Let's go meet them where they live. So Podman 3.0 is the Compose release. That was our let's be compatible with Docker Compose, the other big thing that people wanted. But Podman 3.2, we sneak in something called Podman Machine. That's the ability to create virtual machines and the ability to, with those machines, run on non-Linux operating systems. The initial version is exclusively QEMU, and it is really, really gross in retrospect, but it did work. And another thing we're trying to do at this same time frame, the 2030 time frame, is we want an identity. Because alias Docker equals Podman. It was brilliant at first, but it's simultaneously limiting. Why should I use Podman as opposed to Docker? At this point, we have integrated rootless. We've made rootless really good. We have daemonless, so we can say we're more secure. We're better for edge systems, but it would be so much better if there were things we could do that Docker couldn't. If there were solid reasons why I could tell you, this is why you want to use Podman. This is something you can do here and nowhere else. Part of this was pods. We introduced pods with version 1.0 even, just to get that ability to integrate back into Cryo that we were expecting, just to have the ability to run Kubernetes. But from there, we start thinking, what if we could have better Kubernetes integration? This would let us be an on-ramp and off-ramp into OpenShift. We can take containers from developer laptops, generate Kubernetes YAML from them, and then pretty trivially get that running on an OpenShift cluster. That makes a lot of sense. If your YAML's not working, run it on your local system, Podman PlayCube. All of this made a lot of sense, and it's our first real strike into defining our own identity, doing something that Docker really refused to do. The second strike after that is something called Podman Generate Cube, which appears, I want to say, in the 2.1, 2.2 area. And that is the ability to take containers and run them natively under systemd as services. This is something Docker could never do, and it's largely down to our daemonless architecture. Because we're fork exec, we can run pretty natively underneath a systemd unit. It knows what it's talking to, as opposed to Docker, where it's a service, and there's no direct relationship between systemd and that container once it starts. So this was a major advantage. And generate systemd initially was just supposed to manage existing containers, but we pretty rapidly introduced what we call generate systemd -new, where the entire container is created by the unit file, all aspects of it are managed by that unit file. And that, I think, was by far the more interesting and useful bit we could do from there. And also, with that, we want to get some additional integration here going with Builda and Scopio. We had this original idea of, we have these three tools, they're complementary, it's the Unix model. Everything does one thing and it does it well. But now we have three tools that do different things that have very little integration between themselves. Should we add some stuff to Podman so we can see Builda containers? Basically, we have to start thinking as part of an ecosystem and not just a single project. This is where we start doing that. And then 2022 happens, and Podman 4 is the point where people generally agree that things got really stable. This is when major breaking changes really stop happening. And that's not any massive sudden structural shift. This is just, at this point, I want to say 4 years of consistent bug fixing, just addressing upstream reports, addressing downstream reports, trying to get things working as best we could. And finally, it all adds up. The big stuff is gone. And this is also our first big networking improvement release. Previously, we were using something called CNI, the Container Networking Interface. This is standard Kubernetes networking. It worked well initially. It had some pretty serious downsides. It's meant for clusters. We're not a cluster. And in the end, the CNI maintainers basically told us, we only really want to support the Kubernetes cluster use case. What you're doing is not interesting to us. So we end up having to write our own stack, which in the end, I think has been a pretty big boon for us. We've been able to evolve independently of Kubernetes, and we've done a lot of things that are unique to Podman. We are presently, I believe, the only major container platform that has NF table support. And that's, if you saw the previous talk with me and Ashley, that is a pretty significant performance boon. 4.4 also sees something pretty interesting in Quadlet. So Quadlet is originally an idea from the Red Hat Automotive team, who saw Generate Systemd but thought that we weren't going far enough. Our Generate Systemd is we take an existing container and we turn it into a systemd unit file. But Quadlet is, we have this declarative file that is in basically systemd syntax. Like, you can put all the systemd stuff you want in there. It's a standard unit file, except it's got some additional bits to say this is a .container. Here's all your container details. This is a .build. This is how we're going to build an image. This is a .network. This is a network that is going to be set up that your other Quadlets can use. So Quadlet makes things declarative, and this solves a significant problem we had with generate systemd, where the problem is that unit files are not necessarily static. Our understanding of how to build the best unit file for a container changed over time as systemd introduced new features, as we realized we could take advantage of existing features. So if you generated a unit file with Podman 1 and Podman 2 and Podman 3, they looked very little similar. There was a lot of difference, and people weren't just regenerating every release. So we end up with people running these old unit files that we know have bugs, and our solution to that is just tell them to regenerate it, but the people keep coming back, and they keep telling us, this is broken. Quadlet doesn't have that problem. Quadlet generates a new unit file every time it's run, so if there is anything new that we realize we need to do, we add it to the Quadlet generator, and it just works. Next up, Podman Desktop. Also in 2022, this is about a year after we've started the Podman Machine initiative. So we now have significantly improved support for running containers in virtual machines. I'm not going to say it was perfect yet, but it's getting there. And we are thinking that it's time to introduce a better developer product. So we were trying to compete with Docker Desktop, but we didn't have a GUI. Docker Desktop did, and it was a pretty good one. So we decided to spin up a project focusing on developers. It's a separate project, but it's closely related, obviously. Both our teams talk on a regular basis. And then, after, I want to say, 6 months of development, Docker decides to go and make Docker Desktop paid for organizations. Everyone goes out and starts looking for an alternative. They try Podman Desktop. It's still very new. It's still probably beta quality. And they look elsewhere, largely. Some people do stick, but I think one of our big missed opportunities is that we didn't have 12 additional months here to work on this, to get this polished and refined. Because if we had that time, I think a lot of people would have actually stuck. And yeah, curse Docker for doing that when they did. Next up, Podman 5. This is when things start to get really boring. We are transitioning from the fun early days of, oh God, we're missing this feature, let's code it up real quick and ship it out, to we're doing everything that's really necessary, but it's time to start getting really stable and really good. And unfortunately, getting stable in some cases means addressing the sins of the past. In this case, our tragic early understanding of how virtual machines work. Podman Machine needed a extensive rewrite to be truly relevant and competitive, and that led to some breaking changes, but I think what we have produced in the end has been a lot better. One big thing here, we are switching our release cadence. Prior to this, every year we're doing a major release. 19 is 1.0, 20 is 2.0, 21 3.0, but now we've gone from 22 to 24 with only one major release. We're slowing down the release cadence. There is less major work to do, and honestly, what we have is an increasing group of users who are using Podman and expecting it to stay stable. Back in the Podman 1.0 days, our policy was if there is an incompatibility with the Docker API and we have to fix it, even if that's a breaking change, we're doing it because it's not a breaking change, it's a bug. If it's an incompatibility with Docker, we will treat it as a bug and fix it even if it breaks people. That doesn't really fly anymore. Podman has grown to such a point now that if we want to do breaking change releases, we cannot just say, oh, we're going to do an async fix to Podman inspect that will break 500,000 people's workflow. Not acceptable. We have to get to a point where these changes happen less often. They're very clearly communicated in advance. There's an expectation of what's going to happen. and people have time to adapt. And 5 is also our big Podman desktop release. This is when we start more closely aligning with desktop's needs, because there was a lot that we needed to do to be really competitive in that area. This is when we start really focusing over there. 24 to 25. This is Podman moving to the CNCF. It was announced 24, but happened in, I want to say, early 25? Yeah, December 25. So the big impetus behind this is really contributors. Contributors and community. We had talked about CNCF in passing before this, but we really needed a push to get us over there. And that push was just realizing that we were not growing our community the way we wanted to. So from this, we really want to get a few things. We want to attract some contributors. We had a couple other tools come over with us. Podman Desktop and Bootsy are already in the process of being contributed. I think that's what got the idea in our heads and got it to actually happen. And the other big thing is openness. So we've been doing open community meetings and things of that nature for a while, but still, it was very much a Red Hat shop. We had only Red Hat maintainers, very much a project dominated by Red Hat. We're trying to fix that. We're trying to change that now. We're being a lot more open with how we handle new releases. If you go on the Podman GitHub right now, you can see there's a high-level design for Podman 6 out. That's not coming out for another 6 months, but we are publishing our plans for what's going to be in it already. That's going to be our policy going forward. All major changes will be communicated and signposted upstream. And finally, we are presently in the CNCF sandbox. For anyone familiar with CNCF, there are multiple levels, and we are eager in moving up that ladder. I think we've had discussions internally. We think we're about ready for incubation. There are some things that we still want to check up on the community and adopter standpoint, but it's not that we think we aren't ready. It's that we mostly think we have to get everything documented nicely and make sure we pass this first time. 26, Podman 6. This is going to be a spring release, and this is a focus on experience release. This is a relatively small for a breaking change release, in that we're only really going to break your configuration files, and then only in some very specific circumstances. So right now, there are something like 3 different big configuration files. You have containers.conf, which is where you configure all your containers, storage.conf, configure your storage settings, registries.conf, configure registries. Self-explanatory, live in 3 completely different places, behave in 3 completely different ways. What we're going to try and do is unify them so there is a unified set of expectations around this is the first place that we get these files from. If they're not there, we go to here. If they're in both places, we're going to layer them on top of each other, stuff like that. So people can have a reasonable expectation of what happens when they use a config file. Podman Machine, pretty significant changes incoming there in that previously we had a concept of virtual machine providers. So our original idea for this was we'll just use QEMU everywhere. Turns out the QEMU on Windows and QEMU on Mac are suboptimal. So we end up with having native Windows and native Mac hypervisors. And that is not a perfect situation because it turns out there's no perfect hypervisor on Windows or Mac. So we have people who want to be on WSL, but we also have people who can't use WSL or don't want to use WSL because it has some serious limitations. It's actually a Microsoft-provided kernel that's missing a bunch of stuff. So those people want to be on Hyper-V. We end up providing dual implementations for hypervisors for Windows and Mac, and you have to set between them with a configuration file, and once you've set them, you cannot easily change back. We figure that this is probably a bad idea because, as I said, there is no perfect solution. People do want to be, maybe you want to have your Mac OS libkrun VM that's going to have GPU support, but you also want to have a Apple HV VM, the native Apple hypervisor, that's going to have Rosetta, the ability to run really fast x86 code. So yeah, we are going to break the barriers between providers and let you use multiple types of virtual machines easily. And then finally, we're going to do some general cleanup work, remove some stuff that people aren't using, And probably we're going to do a rewrite of Conmon. This is our behind-the-scenes utility daemon that handles things like logging. I'm hoping that out of this, we're going to get a lot more logging capabilities, the ability to do plugins. So we've had open requests for 5 years asking us to add Splunk support. Maybe that'll finally happen. And then the future. Plugins, let's think about plugins at some point after 6. Give people the opportunity to integrate their stuff into Podman more directly. I was talking about logging plugins. Maybe we can do storage plugins. Maybe we can do plugins into the command line. Storage changes. Right now, the container storage backend is kind of old. It has some serious legacy problems. If we were able to store containers in a better way, if we had better artifact integration for that, would that be better? Probably yes. BuildKit API support. This is an exciting one because it would let us have better Compose integration, but I don't think many people really care about it beyond the fact that it's blocking Compose. And then finally, performance. I talked about this at my previous talk, but we're going to be doing regular analysis of Podman's performance versus itself and potentially versus Docker as well to see where we can improve. And then you can see my brief, somewhat AI-assisted attempt at a timeline. Yeah, less said about is the better. And yeah, thank you everyone for coming. Any questions?
So how do you see Podman changing in future as far as the licensing perspective is concerned? Do you think it may overnight change into private?
No, I don't think so. We're CNCF now, so we are completely donated to the CNCF, and we do not. Red Hat does not own the code anymore. I shouldn't say we don't own the code because I am still a core maintainer. All the maintainers moved over to CNCF with us, but the code itself is owned by the Linux Foundation, and now that it's held by a neutral third party, we're hoping that's going to guarantee, one, we don't see that sort of proprietary shift, but also, two, we get some non-Red Hat blood in the contributors.
Any other questions?
Actually, more of just a comment, but I always appreciated Podman's story of being able to, the connection to Kubernetes, right? So start on your local machine, make something work, and create make it easier to transition to Kubernetes. So I always liked that story. I thought that was a good story. But I'm in sales, so. And then Podman 4, I would say the polish on Podman 4 really showed. Like when that came out, I remember going, "Oh wow, it's really grown up." Like I thought that really showed.
Yeah, thanks. The Kubernetes thing, I mean, that came out of our initial let's replace Podman Compose conversation, or not Podman, Docker Compose, which was like we could support this complete separate format, this third-party thing, or we could just try and integrate with what we actually have. Made a lot of sense.
So have you done any benchmarking? I'm sure you do a lot of benchmarking compared with Docker especially. So have you done similar things with other Docker-like stuff like obtainers?
No, I would say at this point we're still benchmarking Docker. Like early on, we said that we were the RC Cola to Docker's Coca-Cola. I think we're Pepsi now, but we're still. It's a duopoly in my eyes. It's us and Docker, and everyone else is so small as to honestly not really be worth mentioning.
Got you. So I'm from HPC space. We love obtainer for rootless and being this and that.
I have regular calls with some HPC people using Podman, and they seem very satisfied. I'll say that.
All right, good news. Thank you.
So I have a question.
Sure.
Why have we not moved to the sandbox stage yet? So I
Oh,
think
we are
we are
sandbox.
sandbox. Why haven't we moved to the next level? That's in.
Oh, largely because there is a 6-month queue. Uh, CNCF is very backlogged right now. They are actually merging with another organization. So right now they are like split between let's merge organizations and let's do actual CNCF stuff. And my understanding is that this has led to there being an extended backlog. So we want to jump on the incubation train, but at the same time, if we mess this up, it's going to be at least a year before we get a chance to try again. Like there will be no second chances just because of the size of the backlog. So we're trying to do it really right. We do not want to screw this up.
Got it. Makes sense. Thank you.